Genre: Expository text. When is a planet not a planet? The Story of Pluto by Elaine Scott. Essential question: how can scientific knowledge change over time? Read about how knowledge about our solar system has changed over time. My very eager mother just served us 9 pizzas. A silly sentence, yet school children have memorized it for years because it helps them remember the planets in our solar system. The first letter of every word stands for a planet, in the order of how close it is to the sun. My very eager mother just served us 9 pizzas. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Mercury is the planet closest to the sun, and tiny Pluto is the farthest away. That is, until recently. Pluto is still there, of course, along with the planets, asteroids, comets, meteors, and bits of space rock and ice. Pluto is part of our solar system. Pluto and all those other objects orbit or travel around the sun. My very eager mother just served us 9 pizzas. This is a composite of photos taken on many different NASA missions. It illustrates our solar system. The wispy tail of a comet is shown in the lower left, and the Southern Ring Nebula is near the lower right. The other faint objects in the image are artistic additions, created with a computer. However, on August 24, 2006, the International Astronomical Union, IAU, a group of individual astronomers and astronomical societies from around the world, made an announcement. They declared that Pluto was not a planet. Suddenly, my very eager mother just served us 9 pizzas didn't work anymore, because now there are only 8 major planets orbiting the sun. Perhaps someone will create a new sentence to help us remember their names in order. Names are important, but they're not the only things to know about the planets. Learning how planets form, where they are located, and what they are like is the kind of activity that makes science exciting and fun. Pluto's problems. There are 2 groups of planets in our solar system. The planets closest to the sun, Mercury, Venus, Earth, and Mars, have a solid surface made of a mix of rocks, dirt, and minerals. The planets farthest away from the sun, Jupiter, Saturn, Uranus, and Neptune, don't have a solid surface. They are made up mostly of gas, with a rocky core. Scientists have a theory about why some planets are terrestrial, or made of rocks and dirt, and why some are composed primarily of gas. Most scientists believe that our solar system began as a space cloud, called a nebula. The nebula was made up of bits of space dust, rocks, ice, and gas. A tiny star, not yet ready to give light, began to form in the center of the nebula. The star was our sun. As years passed, the sun grew big enough that high temperatures and extreme pressure caused hydrogen at the center of the sun to begin to fuse into helium and release energy as light, sunshine. Meanwhile, the nebula continued to orbit the new sun until it formed a large, flat ring around it. Scientists call this ring a protoplanetary disk. The disk, or ring, was hottest where it was closest to the sun, and coolest at its outer edge. As the disk swirled around the sun's gravity went to work. It pulled and tugged at the bits of rock, dust, ice, and gas, until they came together in clumps of material we now call the planets. An artist's conception of a protoplanetary disk forming around a star. The planets that were closest to the sun didn't keep much of their gas. The sun's heat blasted it away, leaving behind solid spheres of matter with only a little gas. Those spheres became the terrestrial planets: Mercury, Venus, Earth, and Mars. But on the outer edges of the disk, far away from the sun's heat, it was much cooler. The clumps of rock and dirt there still had their thick layers of gas. They didn't burn away. The planets farthest from the sun became the gas giants: Jupiter, Saturn, Uranus, and Neptune. a small portion of the Orion Nebula, 1,500 light years away from Earth. At least 153 stars in this region have protoplanetary disks swirling around them, forming new solar systems. Scientists believe our solar system formed in just this way. Because astronomers still believed this theory about how our planets formed, they had a problem with Pluto. When it was first discovered in 1930, astronomers assumed Pluto was made of ice and gas because of its great distance from the Sun. However, by 1987, Pluto had moved into a position that only occurs twice in its 248-year orbit, and scientific instruments had improved. Astronomers were able to study Pluto and the light that reflected off it. Their instruments told them that Pluto was dense and must have a rocky core. That new information raised questions. If the planets closest to the Sun were rocky, and the planets farthest away from the Sun were mostly made of gas, why was Pluto, the most distant planet of all, made of rock? Crust, mantle, liquid outer core, solid inner core. Earth is a terrestrial planet, which means it has a solid inner core. Mantle, molecular hydrogen, metallic hydrogen. Core, though they are made almost entirely of layers of gas. Jupiter and other gas giants have a small solid core. There were other questions as well. Pluto's orbit is different from the orbits of the planets. Think of an orbit as a lane on a racetrack. Just as runners have their own lanes on the track, each planet has its own orbit around the Sun. For the runners, all the lanes together make up the racetrack. For the planets, all their orbits taken together make up the orbital plane. Just as runners don't run outside their individual lanes, planets don't travel around the Sun outside their individual orbits, except for Pluto. Pluto crosses Neptune's orbit. Pluto's orbit. Neptune's orbit. All of the planets, comets, and asteroids in the solar system are in orbit around the Sun. Their orbits line up with each other, creating an imaginary flat disk called the orbital plane. Pluto's orbit, which takes 248 Earth years to complete, brings it outside the orbital plane. For 20 years of each orbit, Pluto moves inside the orbit of Neptune, making Neptune farther from the Sun than Pluto. Pluto was inside Neptune's orbit from 1979 to 1999. The shape of Pluto's orbit is different too. The larger planets travel around the Sun in an oval-shaped orbit. Pluto's orbit is more of a stretched-out oblong. The other planets' orbits are level with the Sun. Pluto's is tilted. Comets' orbits are often tilted, so astronomers wondered, could Pluto be a comet? And of course there is Pluto's size. Astronomers knew Pluto was tiny when it was discovered in 1930, but because it was so far away, it was hard to see the planet clearly. Pluto appeared as a tiny dot of light in the night sky. Then telescopes improved. In 1976, American astronomer James Christie discovered that the tiny dot everyone thought was Pluto was really two objects. Pluto had a moon, Charon, Care-N. Once astronomers discovered that Charon was separate from Pluto, they realized that Pluto was even smaller than they had originally thought. Pluto was only 1,440 miles in diameter. Charon's diameter is 790 miles. They began to ask, is Pluto too small to be a planet? And since they had found Charon, they wondered, were there more objects out there the size of Pluto? Were they planets too? Pluto and its moon Charon. Pluto was 2.6 billion miles from Earth when the Hubble Space Telescope took this photo. Finding planets. In 1992, astronomers made an amazing discovery. 9.3 billion miles away from our Sun is another region of space, shaped like a disk. Astronomers believe it contains approximately 70,000 icy objects, including Pluto. This area of space was named the Kuiper Belt, after the Dutch-American astronomer Gerard Kuiper, Kuiper, who lived from 1905 to 1973. In 1951, more than 40 years before its discovery, Kuiper actually predicted that a region like this might exist. Michael Brown, Chad Trujillo, and David Rabinowitz are planetary astronomers who study Kuiper Belt objects, or KBOs. People often call these men the planet finders. Together they hunt for planets at the outer edges of our solar system using the Samuel Ocean Telescope at the Palomar Observatory in California. The Ocean Telescope is a wide-field telescope, which means it views broad regions of the sky at once. When paired with a camera at the observatory, it can take pictures of these large areas. In the past, astronomers had to spend their evenings peering through telescopes in order to study the night sky. Now things have changed. Robots control the Ocean Telescope and its camera. In the evenings, the cameras in the telescope at the Palomar Observatory are at work. They take 3 photographs over 3 hours of the part of the night sky the men want to study. Any object moving across the background of billions of stars and galaxies will be captured in pictures. The pictures are then sent from the telescope's cameras to a bank of 10 computers at the California Institute of Technology. Next, the computers decide which objects appear to be moving, and therefore might be a planet. Usually the computers select about 100 objects. When the men arrive at work each morning, the pictures are ready for them to view. Objects in the Kuiper Belt are so far away it takes them hundreds of Earth years to orbit the Sun. Mike Brown says most of the objects he looks at on his computer screen are not planets. Many are caused by some kind of flaw in the telescope's camera. But every once in a while, an astronomer will get very lucky and something new and exciting will appear. That's how Mike and his team discovered 2003 UB313, or Xena, Z-Na, as it was nicknamed, on October 21st, 2003. Mike says, "The very first time I saw Xena on my screen, I thought that there was something wrong. It was too big and too bright. Then I did a calculation of how big it was and how far away it was. Xena is the most distant object ever seen in orbit around the Sun. Pluto is 3.6 billion miles away, but Xena is 10 billion miles away and is approximately 400 miles bigger in diameter than Pluto. It takes Xena more than twice as long as Pluto to orbit the Sun." Xena was always a nickname. On September 13th, 2006, the newly discovered celestial body officially became Eris, Eris, for the Greek goddess of strife and discord. It seems an appropriate name, since there was a lot of strife and discord surrounding Eris. Was it a planet or not? They called David Rabinowitz, left, and Chad Trujillo, upper left, and Mike Brown, center, the planet finders. The team used the Ocean Telescope, right, to discover Eris. What is a planet? Because scientists always check and recheck their work, Mike Brown and his team of astronomers didn't announce their discovery of Eris until January 5th, 2005, after they had had a chance to verify their information. When they revealed their discovery, many people thought the solar system had gained its 10th planet, but others disagreed. Soon an argument was raging among astronomers all over the world, and the argument came down to one question: what exactly is a planet? It seems surprising, but until August 24th, 2006, science had never had a definition for the word planet. Dictionaries had definitions, of course, but most said something similar to a large celestial body that circles around the sun or another star. For a scientist, That definition had problems. For one thing, what is meant by large body? Jupiter, the largest planet in our solar system, is 88,700 miles in diameter, and it is a planet. Pluto is only 1,440 miles in diameter, and, at the time, it was a planet too. The question, what is a planet, needed an answer. And the International Astronomical Union decided to create not one definition, but three. An artist's conception of the Milky Way, our home galaxy. A galaxy is a group of billions of stars and their solar systems. The Milky Way is a spiral galaxy that contains 200 billion stars. The IAU came up with three classes of objects that orbit the Sun: planets, dwarf planets, and small solar system bodies. The IAU decided that a celestial body is a planet if it 1. Orbits the Sun, 2. Is round or nearly round, because its gravity has pulled it into that shape, 3. Is big enough and has enough gravity to clear the neighborhood around its orbit. The first two qualifications for planethood, orbiting the Sun and a round shape, are easy to understand. The concept of clearing the neighborhood is a little more difficult. It might help to think of planets as the schoolyard bullies of the solar system. In order to clear the neighborhood, a planet has to be big enough and have enough gravity to get rid of any celestial objects in its way. A large planet might clear its orbit by using its gravity to pull other smaller objects toward it and destroy them, the way asteroids are destroyed when they hit Earth. A cosmic collision. Planets often clear their neighborhoods in this manner. Or a planet might clear its orbit by attracting smaller objects toward it, then turning them into moons that remain in orbit around the planet. Sometimes a planet will simply push a smaller body into a completely different orbit and get rid of it that way. But no matter how it does the clearing, according to the IAU definition, a planet must travel in its orbit by itself. The secondary category of planets, called dwarf planets, have the following characteristics. They must 1. Orbit the Sun, 2. Be round, 3. Not be a moon or satellite of another planet. By this definition, Pluto is a dwarf planet, and although Charon, its former moon, is still locked in an orbit with Pluto, it is a dwarf planet too. Now they are known as a double planet system. Ceres is a dwarf planet also. In Mike Brown's discovery, Eris is one as well. They are dwarf planets because they orbit the Sun, they are round, and they are not moons of another planet. But they're too small to have enough gravity to clear their neighborhood. Pluto, Charon, Ceres, and Eris are all KBOs, orbiting far out in space with other objects in the Kuiper Belt. Everything else, asteroids, comets, meteors, are now members of the third class of objects that orbit the Sun and are called small solar system bodies. Some astronomers think the definition of a planet will change again in the future. Others think the current definition is a good one and will last. Science is exciting because it continually changes as new information is discovered. A long time ago, we thought there were 6 planets. Then we thought there were 8. For a while, there were 9. Then it was back to 8. Then with Pluto, the number jumped up to 9 again. And now it's back to 8. And that is just in our solar system. An artist's conception of the New Horizons spacecraft as it arrives at Pluto. Charon is visible in the distance. We know our sun is not the only star that has planets in orbit around it. New planets are forming around other stars, making new solar systems. There are 200 billion stars in the Milky Way galaxy alone, and there are billions of galaxies full of stars in the universe. As we study those planets and the stars they orbit, we ask questions. Are there other planets like Earth somewhere in the universe? Does life exist on them? We ask questions as we study the planets in our own solar system too. Does life exist on one of them? or even one of their moons? Did life ever exist on any of them? Is Earth the only planet with life? Are we alone in the universe? In January 2006, NASA launched the New Horizons mission to Pluto. If all goes well, the New Horizons spacecraft will reach Pluto and Charon sometime in the summer of 2015. Then instruments aboard the spaceship will begin to get a close look at these distant worlds. As the information beams back to Earth, scientists here will study it, trying to learn more about the origins of our solar system and what lies at its outer edges. Pluto still has a story to tell. There are questions that need answers, and the answers will come through science. New information is just waiting to be discovered.